So today we're going to start multiplying and dividing our rational expressions. The first step is still going to be factor everything. Then after we factor everything, we're going to go ahead and divide out our common factors. So just like we did yesterday when we were simplifying. And then we're ready to multiply using the same rules we use with regular number fractions, which is to multiply straight across. So when we have monomials, factoring is pretty much the same thing as expanding. So for a squared, I can write 4 and then a squared. I have 2 a's. Here I'm going to expand this out, so I have 5 and a, 3 b's. I'm multiplying that by 3 BC, and then here 12, and then 3 a's. So what do we have in common in the numerator and the denominator? So I have an a and an a. So if you remember, multiplying with numbers, you can also reduce your fractions this way. All right, a b and a b, and that is it. But I do know that 4 divides into 12. So 4 divides into 4 one time, 4 divides into 12 3 times, and then look, 3 divided by 3 is 1. So what do we have left? In the numerator, I have a c. In the denominator, I have a 5. I have a times a, so I'm going to go ahead and write a squared, and I have b times b, which is b squared. So this would be multiplying. So then, if I look at example 2, this is more like our examples that we were working on yesterday. So to factor the numerator here, 1 times 12 is 12. My factors of 12 are 1 and 12, 2 and 6, 3 and 4. I want a negative 8 when I add them together. So negative 2 times negative 6 gives me a positive 12, and when I add them together, I get a negative 8. So that is going to be my factors that I use there. So I am going to save time and space by writing this factored form here. For my denominator, I notice that this is a difference of 2 squares. The square root of 16 is 4. So I can go ahead and write that as a sum and difference of x and 4. Okay, I'm multiplying. Up here, I have a GCF of 4. 4 divides into that x times. 4 divides into 16 4 times. And then the denominator, I'm going to factor that also. So 1 times 4 is 4. Factors of 4 are 1 and 4, 2 and 2. I want a negative 4. So again, I'm going to make both of those negative, because when I multiply, I get a positive 4. And when I add, I get a negative 4. So fast forward, my factors are x minus 2 and x minus 2. So what common factors do we have? I have an x minus 2 here. Now remember, when we cross off our common factors, we have to have 1 in the numerator, 1 in the denominator. We cannot cross off sideways. So x minus 2 and x minus 2. Here's an x minus 6, but I do not have one of those in the denominator. Here's a 4. I do not have a 4 in the denominator. X plus 4, and then an x plus 4. So I can cross those off. So what do I have? I have 4 times x minus 6. And in the denominator, I have x minus 4. Oops. And x minus 2. We can double check to make sure that we can't simplify more, that we didn't miss something, and we can't. Remember that this 4 and this 4, we cannot divide those out because this 4 is connected to the x. This is one thing. So we are finished with our simplifying. You could multiply it out, but I'm not asking you to. I am perfectly happy with you leaving it in factored form. Okay, so now is a good time to pause the video, try the examples that are here, and then you can check back and see how you did. So here, if I'm going to factor this, I have 6a plus 12, so that has a GCF of 6. And here, if I expand this out, I don't have to, but I can. That might help me. And then I have a plus 2 here. So what are my common factors? I have an a plus 2 and an a plus 2. I have an a and an a. And that just leaves me with 6a squared. I have nothing in the denominator. So 6a squared is my answer here. When I come to this example, this is a difference of 2 squares. So it's y minus 5 times y plus 5. This is 2y. This is 5y. Nothing I can do here. And this is a y plus 5. All right. So what do we have in common? We have a y plus 5. We have a y. 5 and 2 don't simplify. So in the numerator, I have 5 times y minus 5. In the denominator, I have 2. So that is answer choice C. And then our last example, I have a GCF of x for my numerator, first numerator. I can factor this. 1 times 6 is 6. Factors of 6 are 1 and 6, 2 and 3. I want a negative 5. So I need both of these to be negative to give me a positive 6. And when they add, they give me a negative 5. So that is going to be x minus 2 times x minus 3. This, all I need to do is just expand this. X minus 2 times x minus 2. And then 2x, I'll just write it the same way. So what do we have in common? I have an x and an x. I have an x minus 3 and an x minus 3. I have an x minus 2 and an x minus 2. So basically everything went away but that x minus 2. Oh, and the 2. C is my answer choice. All right, so when I am dividing, I am basically multiplying. So if you remember the rules for multiplying fractions, you multiply by the reciprocal. Whoa, reciprocal. I was told a long time ago from a student, keep, change, flip. I do not know if they teach that, but that's what you do, or that's a way to remember. And we'll talk about that in a minute. So again, we're going to factor everything. And we are going to cancel the common factors. And then we're going to multiply. So same steps with division. So if I keep the first equation, first fraction, change division to multiplication, and flip the second fraction. So 12y will be in the numerator, 10w squared will be in the denominator. So that's keep, change to multiplication, flip the second fraction. So what do we have in common here? I have a W and a W. That's too particular. A W and a W, a Y and a Y. So 15 and 10 are both divisible by 5. 5 goes into 10 2 times. 5 goes into 15 3 times. 4 and 12, 4 divides into 4 1 time. 4 divides into 12 3 times. So what do we have here? We have 3 times 3 is 9. I do not see anything else. And 1 times 2W is 2W. All right, for example 2, let's go ahead and see what we can factor. X plus 2 we can't do anything with. This is a difference of two squares. X minus 2 times x plus 2. I'm going to change this to multiplication, and I'm going to flip. X minus 2 is in the numerator. X plus 3 is in the denominator. So x plus 2 and x plus 2, x minus 2 and x minus 2. Be careful here. I am left with x plus 3, and that is in the denominator. It has to stay there, and we put that 1. That little 1 that's always there in the numerator. So here are 3 examples for you to try, and then so you can pause the video, try them, and then check at the end. So here I have a difference of two squares again, x minus 2 times x plus 2. X minus 8 cannot be factored. This I can make into a fraction by putting 1 under it. So put 1 in the top, x minus 2 in the bottom. Oops. So what do we have? We have x minus 2 cancels with x minus 2. All right, our answer now, we have 1 times x plus 2, which is x plus 2 divided by x minus 8. So D. For my next example, I have all of this. So I have x, y, I have 3, I have 5 a's. Oh, that's a lot. And 4 b's. And you don't have to expand it out if you can see it or visualize it. I'm changing this to multiplication, and then I'm flipping this. So it's going to be 5a to the 7th over b to the 3rd, and 31x to the 5th over y. So 5a to the 7th, or 7a's, and 3b's, over 31x, x, 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 and y. All right, let's start crossing off. A. Oops. And then B, B, B. Y. All right, I think that's everything that I can get rid of. So I have 5 y squared. I have 3b. Here I have 5a squared. 31, 1, 2, 3, x to the 3rd. All right, so 5 times 5 is 25. A squared y squared divided by 3 times, oh, that's what I did. This is a 15. So I can actually simplify this. 3 divides into 3 1 time, 3 divides into 15 5 times. So here we have 31 b x to the third. Okay. A different way to do this could be to use your power rules. So if I did 5x squared y to the third divided by 3a to the fifth, b to the fourth, and then times 15a to the seventh, b to the third, divided by 31x to the fifth, y, I can go ahead and reduce like I have been doing. And then I can multiply. So I have 5 times 5 is 25, x squared, y to the third, a to the seventh, b to the third. And down here I have 31, a to the fifth, b to the fourth, x to the fifth, and then a y. And if you recall from Algebra 1, you subtract your exponents when you're dividing. So I have an x squared and an x to the fifth. 2 minus 5 is negative 3, so it's here. All right, I took care of those. Y to the third, y to the fourth. So 3 minus 1 is y squared. A to the seventh, a to the fifth. 7 minus 5 is a squared. And then b to the third and 4. So 3 minus 4 is negative 1. So that means it's in the denominator. And so that's the same answer that I got up here. All right, last example. So this is just another way to write division. So I have x divided by x plus 7, and then division changes to multiply, and then I flip this one. So x plus 7 divided by x minus 9. And my common factor is x plus 7 and x plus 7. Remember, I cannot cancel out these two x's because this is not just x, it's x minus 9. So our answer is x divided by x minus 9. And here is our solution there.